30 times. Ten times more. Two times more. Letting go and stop.
But there's some other rules that are less obvious that come about when we start thinking about things like growth mindset and what's rewarding, what is punishing, what it means to lean in hard to a problem, or what creativity is. But I want to just mention there's one exception to all this, which is very interesting, and it happens to be the one that my lab works on, so I am biased in this regard. But there's one piece of your brain that is outside your skull. In fact, you have two. The rest of your central nervous system is inside your skull and spinal cord, except lining the back of your eye is the neural retina, which is 3 cell layers thick, meaning it's about as thick as a credit card. And the neural retina is not attached to the brain, it is brain. The cells in the neural retina were deliberately placed during development. They got pushed out of the skull and deliberately to sense light events in the environment, and not just the shapes of things and what's moving around out there, but fundamentally to tell the rest of the brain and nervous system when to be alert and when to be asleep, based on how much light is in the environment and the quality of that light. So viewing morning sunlight around the time of sunrise, as well as evening sunlight around the time of sunset, not just at sunset, rise and sunset, but near those times, a couple hours on either side, is fundamental for instructing the brain, a special collection of neurons right above the roof of the mouth, which then instructs all the cells of the body when to be active. It's sort of like you're a factory and you need your digestion to work on a particular schedule and you need your spleen to work on another schedule. And it's morning light and evening light in particular.
Thirty times. Ten times more. Two times more. Letting go and stop.
And the cells that do this, they pay attention not to blue light. Everyone's kind of obsessed with blue light as it relates to this stuff. Wrong. That's only half the equation. It's the contrast between yellow light and blue light. So in the morning and at sunset, yellows are getting brighter. Watch a sunrise or sometime or a sunset. And blues are getting darker. And that contrast is relayed to the brain. You don't perceive it. Even blind people can transmit this information into the brain. And it says, make a cortisol pulse early in the day to give you energy and agitate your body to go be active. And then it times the onset of the melatonin pulse in the evening, which is going to put you to sleep. And so when we think about the brain and the nervous system being isolated, it is isolated, but it's as much as it's a machine and a collection of cells, they need to work together and they need to know when to be active. And so it's viewing of morning sunlight in particular and evening sunlight in particular that anchors everything that goes on from the top of your skull to the bottom of your feet in terms of this basic thing of when to be alert and when to be asleep. And screens, but not just screens and not just blue light, making their way into the hours of, say, 11 p.m. to 4 a.m., do just the opposite. There was a paper published in Cell, an excellent journal, showing that bright light activation between 11 p.m. and 4 a.m. sends a signal from the eye to a brain structure called the habenula. The name doesn't matter, but it kicks off a disappointment circuit. It starts suppressing dopamine, and the habenula is linked to the pancreas, right? The brain-body connection, and starts dysregulating blood sugar.
Thirty times. Ten times more. Two times more. Letting go and stop.
So every circuit in the brain has a push and a pull. So we have a reward system for viewing light at the particular times of day, which are morning and evening and during the day, and avoiding bright lights in the middle of the night. But there's a punishment signal, literally, a chemical punishment signal, whereby dopamine, which is this feel-good molecule that's essential for things like growth mindset and pursuit of goals and well-being of all sorts, is suppressed when human beings or animals view bright light in the middle of this dark phase of their circadian cycle, which is between 11 p.m. and 4 a.m. approximately. And so nature does this. It creates rewards for doing the right things that move you in the direction of general adaptation and wellness, and it punishes you. Mother Nature is kind of a double-edged sword. She's very benevolent when she wants to be, but if you don't obey her rules, she punishes you too. And so you have circuits in the brain that are pro-depressive. And this light viewing from 10 p.m. to 4 a.m. kicks off a pro-depressive circuit. This idea of I'm not there yet, but that I can get there. That's the whole principle behind growth mindset. However, when the discovery of growth mindset is worth thinking about. So Carol's discovery was these kids that, for whatever reason, liked doing math problems even though they knew they couldn't get the answers right. These were sure fail problems. So it's the same kind of people that like doing puzzles. And these kids, not surprisingly, go on to do phenomenally well in a number of different areas of academic pursuit. But what's interesting about growth mindset is that it seems like there's some attachment of the reward systems of the brain to the action or the pursuit of a goal, not just achieving a goal.